The radical reactions is a type of reactions that is quite useful, but by and large, if we think about all those kind of organic chemical reactions, the radical reactions actually it's kind of one of those minor type of reactions. They need many, but those kind of other reactions which involve a pair, which involve the movement of a pair of electrons are more common. So over here, for our particular discussion, this will be one of those kind of points we're going to have a need to focus on this unusual type of reaction, and then later on when we do see the specific examples, we'll kind of mention it again. Okay. But for those kind of radical reactions, the first thing we need to mention something what is indeed radical. Okay. This is one of those kind of features for the radicals. Those are any of the species as long as it has single electrons. Okay? So normally just one, but of course we could have 2 single electrons or 3 single electrons. That could happen occasionally. Okay? But as long as we do have single electron in a particular ion or neutral molecule or something, so the species will be called a radical. Most often, this type of species will be neutral. So how about as one example, as we just seen one of the early kind of reactions, those kind of homolytic and those kind of also homogenic steps, as I show you for you folks. That think about one particular example, which is chlorine. Just think about the chlorine atom by itself. Okay, chlorine of course is kind of one of those halogens. It will be group number 7 element or group 17. It should have 7 valence electrons. If you think about all those 7 valence electrons outside of chlorine, we're going to find out we'll have this. Okay? So if you really think about this chlorine atom by itself, this is actually just one radical. And then, as the name indicates, so now think about this particular word, radical. Okay? So radical, of course, when it refers to people, and then normally we just refer to someone who has kind of some of the extreme sorts. Okay? So sometimes then those it could cause damage to us. So many times we're going to associate a radical with kind of terrorists. Okay? In the sense of chemistry, normally we use radical to describe species which do have high reactivity. Okay? So that's really what chemistry is about. When we do have the radical, typically means radicals are very reactive. So, and when we do have high reactivity, typically also this is kind of more or less equal to So radicals in general, they are not very stable. They like to react with other things. Sometimes they even react with themselves to create something which is more stable. But in themselves, normally they are not that stable. So that's actually one of the reasons when you think about the chlorine. So think about the electrical state of the chlorine gas. So we have a number of the diatomic molecules that would include chlorine, or just inside the halogen group we have Br2, we have I2, and when you think about some of the other related non-metal elements, such as if we do have oxygen, you can remember the formula for the oxygen element is O2. When we think about nitrogen, the formula for this kind of nitrogen gas is N2. Why do we have those particular cases? So such as why the chlorine is not just chlorine by itself, but it needs to be Cl2. Particular reason is that one chlorine atom, it has a single electron that's radical, that's too much reactive. Electrons, if possible, they like to pair with each other. When it's not paired, it's not that stable. So that's actually the reasons. So typically we'll have the normal natural state when it's very, very stable. Chlorine does not exist in the form of radical, but instead two of the radicals kind of combine together, we form this kind of chlorine element. Okay? So that's first thing to talk about, some general comment on those kind of radicals. Okay? The next thing we are going to talk about is how do we think about a particular reaction. And we're going to use one of those kind of reactions as an example. which we just introduced a moment ago, but also it's something relevant in chapter number 3, which is alkanes. We do talk about for the alkanes, such as methane. One reaction that can take place is that we take these two compounds, chlorine plus kind of methane, we give it some UV light, give it some kind of light, kind of shining on it, special light, and we can find out we will have this substitution reaction or double replacement reaction. We will form the chloromethane plus the HCl. Okay? So people have studied this kind of reaction. One thing that's kind of very special about this kind of reaction is that this would be our normal major product, but depending on how we combine the mixture, and we can change the ratio of those two reactants, we can control the reaction time. People will find out for this particular reaction, we can get quite a lot of mixtures out of it. Okay? So this would be the most common one, but it's quite typical. We also have those kind of other little bit unusual kind of reactant. Those would include di-substitution. We could also get tri-substitution. We could get all the way to carbon tetrachloride if we use more of the chlorine. Okay? And then one of the very unusual products that we can get out of this reaction, we would have something like this. Okay? So I can tell you that if we look at this kind of some of those general products out of this kind of reaction, excuse me. We look at top ones, those three plus this one and this one, those are more or less kind of need to make sense. We're just gradually replacing more and more of those kind of hydrogen with the chlorine. Okay? But the one of the particular product will be a little bit confusing. So exactly how do we start from methane? We're going to get rid of like hydrogen. How do we combine the rest of the two of those methyl groups together? Of course, here we'll make this kind of the acid molecule. Normally, we're going to only form very tiny amount of this particular product. Other things will be the major. Okay? So people have studied this reaction. We really try to make sense out of this reaction. So in the very end, so people have just come up to the conclusion based on the experimental evidence. We consider this is one of those radical reactions, so it involves radicals. Okay? So now we're going to just talk a little bit more about the general outcome or general progress of radical reaction. So for a particular general radical reaction, it normally involves 3 steps. The first step is kind of something which is called initiation. And then we have a second step which is called propagation. And then for the very last step, we have the termination. Those particular words, if we really just think about our life, okay? So think about any of the life, well, everything dies. So think about our humans. We got born, so that's the very first step. We can grow and then just get stronger and then grow older and bigger, and that will be our propagation. Okay? Inevitable fate for everyone in the very, very end. So we cannot die, okay, for the reactions. That's kind of like the that's like at the very end. So the reaction is kind of done. It's kind of terminated. Okay? So how about just for this kind of reaction, we think about for the top example, how does the reaction get initiated? So we start from 2 of the chemicals. We give it light. So one thing happens is that chlorine is not very just a stable compound. Methane is much more stable. So we take the chlorine, which has a single bond in the middle. So we gave it a light irradiation. So this is a radical process. There are 2 electrons in the middle. I showed you 2 folks earlier. So 1 electron goes to 1 chlorine. Another electrons go to a second one. We form 2 of the same kind of chlorine atom or chlorine radical. So that's the first step, generating some radical from a neutral species, and we start from something neutral. This chlorine atom just have its own 7 electrons. Again, I only show 1. So like for those other paired electrons, many times we just don't show them. Of course, if you do show all those other 6, that's very correct. There's nothing wrong with it. Sometimes for convenience reasons, we just choose to omit some of those paired electrons. Okay? So this would be our initiation step. Okay? So once we have the initiation, we generate the radical. The second step would be the propagation. So now the propagation step is something which is quite interesting. So now we have the chlorine atom or chlorine radical already. So now we take this chlorine radical, we just react it with methane. So now over here, I'm going to show one of the bond between the carbon and hydrogen. For all the other, like just the 3 hydrogens, I just write them together. Okay. So the steps can happen like this. Okay. So we start from like a bond over here. Let's remove this kind of plus sign. So the process is that there's 2 electrons in between this carbon and hydrogen. How about 1 electrons move this way, another electrons move to the hydrogen, and for the electrons from chlorine that moves to the middle. Okay? So notice that those are 2 species. Chlorine atom is by itself, the methane is by itself. Originally there's nothing. So now we move 2 electrons in the middle. So that means we will form a bond between the carbon and the chlorine, so that would be one of our products, methyl chloride. On the other hand, you see a single electron moves to the hydrogen, so hydrogen will acquire that kind of single electron. So indeed, what do we have over here? That's a hydrogen atom. Okay? Hydrogen atom is actually not stable at all, so it's a very reactive species. That's also another reason hydrogen, when you think about this particular element, hydrogen gas, the formula is always H2, because in the normal stable state, 2 radicals combine. Okay? But in this particular case of this kind of reaction, so that would be our propagation stage. We start from chlorine, we react with a neutral molecule, we find out we get a different neutral molecule, which is one of our product up here, and we regenerate another kind of radical. Okay? So how about now we take this kind of hydrogen radical, okay? The H plus like a single electron. So now what it can react is that, so now look at our product, our starting material. We have the methane, we have the chlorine, okay? In the beginning, chlorine radical react with methane, so now we generate some of those more of those kind of hydrogen. So how about now hydrogen began to react with chlorine? So we have this, get rid of this plus sign, and then now we can do the same thing. We move this electron from hydrogen in the middle. So now 1 electron from this bond moves to the middle, another one of those electrons moves to the chlorine. We find out, so it's one of those reaction of a single radical react with a neutral species. So what we will obtain is that we will form a bond between the H and Cl. We're going to form the hydrogen chloride, and then we will generate the chloride, like just a radical. Okay? So in this particular process, we find out, so CH3Cl methyl chloride is one of our products. If you think about HCl, that's our second major product. Okay? So along the process, and also if you really think about it, this reaction is kind of considered kind of in a cycle. What matters is that we take this kind of chlorine radical. In the beginning, we consume it. We change it to a different radical. So now this hydrogen radical kind of have a reaction with another kind of starting material chlorine. We regenerate this chlorine like a radical again. So actually for this particular reaction, you find out we just need a little bit of a chlorine radical. We just keep the reaction going and going. So along the process, we'll form more and more of those chloromethane and HCl, and then until to a point, when we consume all of them, we're going to have our product. There's no other starting materials to react, and the reaction will be close to the termination stage. Okay? And if you do take those kind of 2 of those kind of steps, adding up together, such as we do think about this propagation step, we add 2 of those kind of reactions together. Starting material, Cl plus methane plus this hydrogen radical plus Cl2. We put all those starting materials of the 2 reactions kind of all together. We put the product of those kind of the things all together. We're going to have H plus, get the hydrogen radical. We're going to get HCl. We will form the chlorine kind of radical. So now we have this reaction 1, this reaction 2. We add them up together. What do we find out? Now on this kind of particular equation, some of the things are the same. Chlorine, we have the same thing over here. We cross them out. We have hydrogen, which is the same on both ends of the arrow. We cross them out to find out what is the end result. So now I'm going to erase to make some space. So now consider for this propagation step. When we do add the things together, we find out what is left over. We have this. We form the methyl chloride, and we have the HCl. Find out this kind of reaction which is on the top. Okay, so that is actually how the propagation step takes place. It just turns and turns until we kind of change everything into the product. Okay, so since we only need a very, very small amount of this kind of chlorine radical, so one of the things I want to make it clear to you folks is that when we do have this particular reaction, we shine some light on those kind of chemicals. So only actually a very, very small amount of the chlorine is dissociated into the chlorine radical, and it could possibly be just 1% or maybe 0.1%. So we only need a very, very small amount of particular radical. And that radical will just keep running and running, and we're going to form more and more of the product to a point when everything is kind of depleted. Okay? So now, once all those kind of radicals or all those kind of starting materials are gone, we are at this termination stage where everything just was low. Starting materials to react, so at the termination stage, it's always that for different radicals to combine. So for this particular process, we have different kinds of radicals. One way we would have those things. So if we do have this kind of the two of the chlorine radical, what they do is that they can form a bond with each other. So we will regenerate some of those kind of chlorine gas. So that's one of those typical kind of process of consuming the radical. Okay? Another process is that we do have the methyl radical, we have the chlorine radical, and how about the two form the bond with each other? So this, of course, will be one of those homogenic steps. So we're going to form the chloromethane. That will be one of our products. Okay? So now comes to about this point, which is kind of can explain the experimental result. How about if we do have two of the methyl radicals? Okay? So now what we find out is that for the two methyl radical, one gave out 1 electron, another one gave out the second one. We will form a bond between two methyls. So in this particular case, we will form the SN molecule. So this is actually the explanation why do we have SN as one of our product. And also because radicals, they're always in minute quantity, their concentration is very, very low. So we only have this at the very end of this reaction, where it's no more of the methane and no more of the chlorine. So two of those methyl radicals now have a chance to really react with each other, and then we form some of those kind of SN molecule. So this is actually very like a tiny, like just a fraction of them, all the products, but this is one of those kind of products which kind of one of the key evidence to show that the reaction indeed goes through the radical process. Okay? So I think that's pretty much we're going to talk about some of the details of this kind of radical reaction. Just remember some of the feature. Initiation, we are going to form keeping radicals from neutral species. We have the propagation. One radical is going to react with something else. We are going to get a lot of different product. We will get a second different type of radical. Whereas at the termination stage, different radicals, sometimes the same type of radicals, many other times different type of radicals, they just combine, make some neutral species, get rid of all the radical, and when there's definitely no radicals left at all, the reaction stops. So that would be the termination.